Hi everyone. Guys, am I audible and visible to you? Confirm once. Hi everyone. And please mark your attendance. Shillong, Tetso College. Can I have one person on the system from both the centers just to confirm that whether am I audible and visible to you? And share your topic that we were discussing in the last class so that we can continue. I'm repeating Shillong and Tetso College. Guys, confirm once and share topic as well that we were discussing in the last class. Mark your attendance and share the topic. Okay, what's the topic we were discussing in the last class? Tell me the topic that we were discussing in the last class. Shillong. No, dear, that has been already over. We have started with the chemical bonding. I think we were discussing about the Lewis dot structures, and I have given you few questions based on that to draw the Lewis dot structures. Lewis dot structures. I have given you homework as well. Okay. So I'm discussing few of the examples that I have given you in the homework. I don't know you have attempted those questions or not, but the situation is currently saying that you haven't attempted those questions. So guys, this is really bad if you are not doing your homework at your home. Okay. This is not the right way to learning. This is really bad. Let's talk about HNO3. I have told you that the arrangement of HNO3 is like this. Okay, complete their octets and draw its Lewis structure. Look at this. 1, 1, 1. Oxygen has total 6 electrons. 1 will be given by nitrogen. 2 will be here. Yeah, over. Look at this. Duplate. Duplet. Octet. There will be dative bond. Octet. Octet. And then octet. Okay. Look at this structure. N, double bond O, dative and single bond. Copy this one. Those who haven't attempted this question, copy and confirm. Copy, guys, and confirm once. Done. Let's move on to the next. I have given you ClO4 minus. ClO4 minus. So arrangement for ClO4 minus is like this. Look at this. 2. Okay. I have told you one method to determine the number of bonds. First of all, check out in ClO4 minus how many bonds will be formed over there. And tell me once, how many bonds will be formed in that structure? How many total bonds? Over? Dear, you have to just complete the octet I have told you the whole method in the previous class. Have you practiced at your home? Dear, just you have to complete the octet. Look out at the number of electrons. Okay. To differentiate, I'll draw the electrons of nitrogen with this green dot. Look at this. Okay. And after that, just complete their octet and you will get your answer. Hi, good evening, Kohima. Now guys, in this question, check out how many bonds should be present. How many total bonds in ClO4 minus? Check out and tell me number of bonds. See guys, if you want practice the Lewis dot structures, it won't get clear to you. I can discuss the variety of the examples with you that I have already done. Okay, I was expecting that you will complete this homework at your home, but you haven't. That's really bad. Now in the class, use that method, total electrons, then valence electron, then shared, then unshared, and tell me how many electrons should be, how many bonds should be there in ClO4 minus, and confirm. Eight bonds. I think electron will be 8. Bond should be 4. See? There must be 3 dative bond. This one will be bubble. And these are the oxygens on the electron. Sorry, electrons on the oxygen. Seven and 1, 8. 7 and 1, 8. 7 and 1, 8. And then this one. Okay? This one should be the answer. And then you can write it like this. Okay, copy. हो गया? I mean over? Now guys, let's draw the Lewis dot structures for the ionic compounds. Okay, first of all, what are the ionic compounds? Or we can say the ionic bond. We'll discuss about the ionic bond. See, a compound which contains the ionic bond will be known as your ionic compound. So we should have knowledge about the ionic bond. See guys, a bond which is found by the transfer of electrons is known as the ionic bond. This is a bond formed by transfer of valence electrons. Okay, that bond is known as the ionic bond. Now, let's check out how the Lewis dot structure can be drawn for this one. Guys, look at this. Let's say suppose this is the sodium, and we have got chlorine over there. Okay, so we know that everyone wants to complete their octet. Okay, sodium has got extra electron and chlorine has got one electron less than its octet. Okay, so what will happen if sodium donates its electron to the chlorine? Sodium will acquire a positive charge, whereas chlorine will have its octet. With a negative charge. Okay, this is how you can represent the Lewis dot structure of the ionic compounds, or you can write it like this as well: Na plus Cl with the electron pairs in a bracket with negative charge. Okay, this is the structure of the NaCl. Copy this one, and after copying, confirm once. Okay. What about you, Shillong and Tetsu College? Guys, have you copied that? If you have got any confusion or doubt, you can please ask me. Again, we are dealing with the valence electrons. Is it clear to everyone? Okay. Let's check out K2S. Guys, look at this. Sulfur has 6 valence electrons and potassium has 1 valence electron. So what is the possibility? That potassium gives one of its electron to the sulfur, and after donating, what will happen? That sulfur will acquire 2 negative charge because it has got 2 extra electrons, and potassium will develop a positive charge. And you can represent it like this: K plus with S2 minus. Okay, this can be the representation for this ionic compound. Copy this one, guys. Copy and confirm. Guys, attempt this one, CaCl2. Remember, calcium has 2 valence electrons, whereas chlorine has 7 valence. So in order to complete the octet, calcium need to donate 2 electrons, whereas chlorine needs to accept 1 electrons. Okay, attempt this question. After that, do KCl as well. Do these 2 questions. This one can be the arrangement. Do these 2 questions. After doing that, just confirm, and I'll draw these structures for you, and you need to confirm once. Okay. Okay, let's start. See, calcium has 2 valence electrons, chlorine has 7. Calcium will donate its electron to the chlorine, and chlorine will look like this. Minus. There will be 2 chlorines with Ca 2 plus. This can be the representation, and this one was quite simple. It is actually similar to NaCl. Donate this electron to this one. This is K plus, and this is your Cl minus. How many of you has got the correct answer? Both answers correct? Okay, I have seen only one hand, Shillong Center. Okay, copy once. It's okay. Yeah, definitely. Even then, it will be a correct answer. See, this one is also correct answer. Dear, bracket has a no sense actually. It is just used to separate the cation and the anion. That's it. Okay. It is used to just separate the cations and the anions. Okay, do this one then. AlCl3. Aluminium has 3 valence electrons. Do this one. After attempting that, confirm once. Okay, check out. See, aluminum has 3 valence electrons. Put 3 chlorines along with these 3. It is exactly like covalent bonds. The only difference is we need not to circle the octet. Okay, here we need to use the arrow to show the octet. See. One second. Minus, plus, minus, minus, and better. Sorry, there will be 3 plus charge. Al3 plus with 3Cl. Copy. Any doubt or confusion? Guys, are you getting the concept that how we are drawing the Lewis dot structures for the ionic compounds? Is it clear to everyone? Okay. Now, drawbacks of Lewis theory. Guys, Lewis theory says that for the existence of a molecule or for the bond formation, it must have octet. Means the outermost shell of an atom should have 8 electrons. In case of hydrogen, they can have 2, even then it will exist. But there are many other compounds which do not follow these rules and still they exist. Okay, so let's check out its drawback one by one. First one was formation of electron deficient species. Let's take an example of BeCl2. Guys, BeCl2 is a very well-known example, a very well-known compound which exists in the nature. But if I use the Lewis theory for the existence of this compound, then might be it won't work. See, beryllium has got the 2 valence electron. Now, if I complete the octet of chlorine, yeah, it is absolutely right. But if I try to complete the octet of beryllium, in anyhow, it will always get the 4 electrons. Okay? So, octet of beryllium is not completed over here. So, according to this theory, this compound shouldn't exist, but yeah, this compound exists. So, this is one of the drawbacks of the Lewis theory, where there are many known examples where central atom won't get completed its octet, but still it will exist in the nature. Okay? So, this is an example. You can copy this one. Copy and confirm. You can say BCl3 is also an example for this one. BF3 is also an example for this one. Okay? There are many examples, guys, available to us. Copy and confirm. Okay. Number 2, formation of superoctet. Guys, check out this example. PCl5. Guys, just check out phosphorus and tell me how many electrons will phosphorus have in its valence shell. Check out the bonds that phosphorus is forming over there, and on the basis of that, tell me how many electrons in its valence shell will have. No. 5 bonds are there, dear. In its octet, it will have 10 electrons. See, we know that if a molecule or a compound exists, and if it form 1 bond, it means 2 electrons are there. If it form 2 bonds, it means 4 electrons are there. If it form the 4 bonds, it means 8 electrons will be there. We can see over here that phosphorus is forming the 5 bonds over there. It means that phosphorus will have 10 electrons in its valence shell. Okay? But according to the Lewis theory, it should have only 8 electrons. So, there is a exceed in the octet. Okay? That's why according to this theory, this compound shouldn't exist. So, there are 10 electrons, which is known as a superoctet. Means, in which the valence shell will have more than 8 electrons, will be known as your superoctet. Okay? Simply what you have to do, you have to pick out the central atom, count its bonds, its surrounding bonds, and then multiply it with the 2. You will get your valence electrons that the particular element will have. Okay? Let's check out this one. Tell me, how many electrons sulfur have in its valence shell? How many electrons sulfur have in its valence shell? Yeah, very good, 12. Again, octet is exceeded over here. So, according to this theory, it shouldn't exist. Okay. Let's check out this one. Tell me, this is the IF7. IF7, how many electrons in its valence shell will have? exactly 14. So again, guys, we can see there are many examples known to us where the octet is being exceeded over there. Okay, so you can copy these examples and confirm once. Copy these examples. Copied. Okay. Then this theory does not tells anything about the shape of molecule. Number 4, formation of compounds of noble gases. For example, XeF2, XeF4, XeF6, etc. Guys, ideally, noble gases itself have 8 electrons in their valence shell. So accordingly, the compounds of noble gases shouldn't exist in the nature. But here, as you can see, that the noble gases can form compounds as well. That's why this is one of its drawback. Yes, this one is also its drawback. Copy this one. Okay. So guys, this theory has these kind of drawbacks over there. Okay. And even this one is also of its drawback, that this theory doesn't we can say does not tells anything about the formation of a chemical bond. Okay. So after being these drawbacks, we have to discuss with a new theory which has overcome with these kind of drawbacks. Okay. So the theory is valence bond theory. Guys, first of all, copy that, and after that, I am discussing something with you. Till then, you won't copy anything. You will just look at the concept. You have, with that, you can copy this one along with me. It states that a bond is formed by the overlapping of valence atomic orbitals containing electron with opposite spin. With opposite spin. This is the main theme of this theory, and this theory is based on particularly on this statement, that whenever a chemical bond is formed, it will always be formed by the overlapping of atomic orbitals, which are the valence atomic orbitals, and they must have the electrons. Okay? So guys, let's move on. Just look at the screen and try to understand this one. I'm considering two hydrogen atoms. We are discussing the formation of H2 molecule. Formation of H2. Guys, consider this one. This is your HA atom. This is your HB. Okay. Initially, guys, these atoms are present at the infinite distance. So, whenever there are any atom present at the infinite distance with respect to the another atom, there will be no attractive or the repulsive force will be acting over them. Okay. So when they start approaching each other, new attractive and repulsive forces will start to operate. Okay. First of all, currently they have got the infinite distance. Okay. Now start approaching. New attractive and repulsive force will begin to operate. Okay. So guys, let's talk about the attractive force first. Guys, we know that the attractive force will act only on the opposite charges, and we know that the nucleus has got the positive charge, whereas the electron has got the negative charge. Okay. So, attractive force. First, between the nucleus of A and electron of B, and nucleus of B and electron of A. These are the new attractive forces which will act. And if I talk about the repulsive force, see, between nucleus of A and nucleus of B, and electron of A and electron of B. Because nucleus has got the positively charged species, or we can say the positively charged center, that's why whenever they will start approaching each other, their nucleus will also experience some repulsive force over there. And obviously, guys, electrons are present at the outside, of the nucleus in the orbit, so definitely they will suffer repulsive forces over there. Okay, so guys, these are the new attractive and the repulsive forces. Now, after having these attractive as well as repulsive forces, I'm saying the two type of forces are simultaneously acting, attractive as well as repulsive. And I'm saying that still atoms are becoming, or we can say are getting closer to each other. Now, can you please tell me, in this scenario, which force will be dominating, attractive or the repulsive? I'm saying two forces are acting simultaneously, but still, after having these two forces, they are still approaching to each other. So, which force is dominating over there, attractive or the repulsive? Can anyone please tell me? Yeah, exactly. What about you, Shillong? Yeah, exactly. Attractive forces are dominating over there. Reason being because they are still approaching to each other. Now my question is, at what point they will stop approaching each other? What will be the state? Means what will be the nature of the forces, or we can say what will be the condition of the attractive and the repulsive forces where they won't get attracted or repelled by each other? At what scenario this is possible? Tell me. Can anyone please tell me? Exactly. When attractive forces are equal to repulsive forces, guys, this is a condition where you said that it is a chemical bond. So guys, chemical bond is nothing but it is a state where attractive forces are not exactly balanced by the repulsive forces. Okay, if these two forces are equal, you will say a system is in the bonded state. Okay, look at this. See, this is your attractive force. This is your attractive force. Okay, these are the old attractive forces between the nucleus of A and the nucleus of the B. Sorry, nucleus of A and electron of A and electron of B and nucleus of B. If I talk about the new attractive forces, these are the new attractive forces. Look at this. One second. Okay, so guys, these are the new forces. New forces. Okay, these are the attractive. Okay, now let's check out. Nucleus of A, nucleus of B, electron of A, electron of B. And these are your new repulsive forces. These are your repulsive forces. Okay. Now guys, I'm drawing the potential energy diagram for this one. And you have to remember one thing, whenever a system is in bonded state, its energy will be minimum. Okay? Because it is a stable system. Look at this one. See, this is the scenario. Atom A and atom B. Here distance is infinite. Okay. They start approaching each other, means they becoming closer to each other. Okay. Coming closer. And a point will come out where they will overlap. Okay. This is the point where they have got overlapped. C. And this is your R, internuclear distance. Okay, here at this point, this is your potential energy on this side. Potential energy minimum. Okay, so guys, this is the whole valence bond theory, which says that a chemical bond will be formed by the overlapping of atomic orbitals. They should have the electrons with the opposite spins. So when they will have overlap with each other, at that condition, net attractive force will be equal to net repulsive force. Okay, and that state is known as the bonded state. Okay, guys, is it clear to everyone? You can copy now. Is there any confusion or doubt? You want me to repeat it again? Copy quickly, guys, and confirm once. Copy all this and confirm. Okay, first of all, copy this one. See, copy this one. I'll summarize it again. This one. Yeah, I'll explain the whole. I'll explain the whole. First of all, copy it. Copy. So guys, what this theory says, see, this theory says that for the formation of a chemical bond, the two orbitals, valence orbitals, which contains the electron should overlap with each other. This is the main theme of this theory. Now, the scenario is, guys, whenever two atoms are present at the infinite stages, guys, these are the atoms that we have taken in the example HA and the HP. Means two hydrogen atom. Okay. Now, at this state, it becomes H2, a molecule. Okay. So, guys, at the infinite distance, whenever they are present at the infinite distance, there won't be any attractive or the repulsive force would be acting between the atoms. Remember, between the atoms, no force of attraction and repulsion will be there. But whenever they will start approaching each other, the new attractive and repulsive force will begin to operate. New attractive forces will be between the nucleus of A and the electron of the B, and as well as between the nucleus of B and the electron of A. Whereas if I talk about the repulsive forces will be operated between the two things, between the two nucleuses and the two electrons of the different atoms. Okay, but the point was that they are still approaching each other. So guys, the point is they will keep on approaching each other until the attractive force will be just balanced by the repulsive force. And whenever this stage reaches over there where attractive and repulsive force are exactly equal, we say that is the bonded state. Means at that state a chemical bond will be formed. Okay, this is how the H2, or we can say any molecule currently, or we can say in this world, will exist according to this theory. Okay, chemical bond is nothing but it is a state where attractive force are just equal to the repulsive force. Are you getting this, guys? Any point of confusion in this one? Now is it clear to everyone? Okay. Important point. The strength of bond depends upon extent of overlapping. Means higher is the overlapping, means greater is the overlapping, stronger will be the bond. Just check out two scenarios. I'm drawing two scenarios for you. Tell me, this is molecule A, this is molecule B. In which molecule the bond would be stronger? In molecule A or in molecule B? According to you, which bond should be stronger? Yeah, absolutely right. Because in scenario A, the overlapping is higher. See, this is the overlapping region, means this is the bond. And see, this is very shorter region in molecule B. So guys, you can check out that in molecule A, there is overlapping, there is a greater overlapping, that's why this is a stronger bond. Whereas in molecule B, the overlapping is less, therefore it is a weaker bond. Okay? Clear to everyone? Can you proceed? Types of bonds. According to this theory, guys, there can be two types of bonds. First is your sigma bond. And second one is your pi bond. This is represented by the sigma, means this is the representation, and second one is your pi bond. This is the pi bond. Okay, we'll discuss about the two types of bonds one by one. Just copy this one and then let's start. So guys, let's move on. Sigma bond. It is formed by overlapping of atomic orbital along their internuclear axis. Okay, it can be formed first SS overlapping. Guys, look at this. Let's suppose this is the S subshell and this is also S subshell. So whenever they will get overlap with each other, it will look like this. And this is your sigma bond. Copy. Guys, internuclear means along their nuclear axis, means a axis which is being passed to the nucleus. Internuclear means an axis which is passed through the nucleus. Okay, along that overlap, along that axis. Copied? Okay. Number 2, sp overlapping. See? Is the shape of the p orbital. Next, pp overlapping. Let's suppose this is the px orbital. This is px and this should also be px. Means both the orbitals should be aligned along one particular axis. Okay, so this is your p overlapping. Copy. Guys, any confusion or doubt in this one? You want to ask anything? Guys, any confusion or doubt? Okay. Next is pi bond. It is formed by sideways overlapping. that is overlapping of atomic orbitals perpendicular to the internuclear axis. Okay, look at this, guys. Let's suppose these are the internuclear axis, these dashed lines, okay, and this is the overlapping. Okay, when this region will overlap with this one and this region will overlap with this one, they will result into the formation of a pi bond. Look at this. So when they will get overlapped with each other, after overlapping, they will look like this. And this is the representation. 1 second. This is the representation for this one. This is your internuclear axis. And these clouds are actually representing the overlapped region. So they looks like this one. Okay, copy. Done. Shillong, have you copied that, guys? Is there any confusion or doubt? Are you understanding the meaning? Okay, let's move on. This is PD overlapping. This p orbital, this is your d orbital. After the overlapping, they will look like this. Guys, these concepts are quite new to you. So please, if you find any difficulty or problem, please you can ask me. Okay? Don't hesitate in asking. See, this is a new type of pi bond. This is how also we can get the pi bond. Copy. Okay. This is DD overlapping. See, this is also you can get the chemical bond. Copy. Okay, guys, so this is how you can get the sigma and the pi bond. So let's prepare a difference table between the pi and the sigma bond, okay, which is very much important for you for the examinations. You can copy with me. Sigma bond. This is pi bond. First, formed by axial overlapping, formed by sideways overlapping, okay. Number 2 involves SS, SP and PP overlapping. Involved PP, PD and DD overlapping. Number 3 free rotation around sigma bond is possible. Here, free rotation around pi bond is not possible. Copy, guys, and confirm once. Copied. Number 4 extent of overlapping is high, therefore it is a stronger bond. Number 4, extent of overlapping is weak, therefore it is a weaker bond. Independent existence of sigma bond. And here, no independent existence of pi bond. Guys, remember, pi bond will always exist with a sigma bond. Okay? Pi bond cannot exist independently. If in a molecule there is a pi bond, there definitely will have a sigma bond. Okay? Copy and confirm. So guys, these are the differences that you have to remember. And if any point which is not get clear to you, you can please ask me. And if not, then we can proceed. If not, then we can proceed. Any doubt, guys? Okay. What about you, Shilong? Guys, is it clear to everyone? Point number 3. Free rotation around sigma bond is possible. Dear, free rotation means the groups attached. Look at this. Let's say suppose this is a sigma bond, which is a single bond, okay? And we said there is a group attached here and there is a group attached here, okay? So we can say that the guys group present on these two sides can rotate freely, means they can move, they can have the motion. See, like this is the bond, and if this is the atom attached to this one, then they can rotate freely. Okay, there is the free rotation. If it has got the pi bond, which is a double bond, then this free rotation is not possible. Okay, if they rotate, the bond will get disturbed, or we can say the bond will get broken out over there. This is the meaning of the free rotation. Now clear to you? If I talk about the point number 5, I'm saying this one. Let's say suppose we have got carbon-carbon single bond. In this, one sigma bond will be there. If you have got carbon-carbon double bond, in this, one sigma and one pi bond will be there. If carbon-carbon triple bond is there, then one sigma and two pi will be there. You can check out, guys, where we have see the pi bonds. Pi bond, along with the pi bond, there is a sigma bond as well. Okay, We have no other examples, or we can say we do not have any example where we can see the pi bond with 0 sigma bonds. Okay, means pi bond cannot exist independently. If there is a pi bond, they should have the sigma bond. This is the meaning of the point number 5. You have to copy this one, guys, because this is quite important for us. This is just an example, guys. So you can take the CC. We have taken the carbon. Okay, you can take any other molecule. Okay, any other scenario. Single bond means sigma bond, 1 sigma bond. Double bond means 1 sigma 1 pi, and triple bond means 1 sigma 2 pi. Okay, copy this one. Copy, guys. Copy and confirm. Now is it clear to you, Shillong? Point number 3 and 5. Okay. Counting of sigma and pi bonds. Guys, look at this. Let's take an example. Let's say suppose we have got CH4. So guys, first of all, we should know the structure of the CH4. Right now, I'll tell you the structures. Okay, you have to just count. Okay, I'll tell you the method by which we can count this one. Okay, this is very much helpful in the organic chemistry. See, the structure of CH4 is actually this one. You can see, guys, one single bond means one sigma. See, sigma bond, sigma bond, sigma bond, sigma bond. Here we can't see any double bond, therefore there is a no pi bond. So we can say in this given molecule we have got the 4 sigma bonds. Okay. Let's take another example. Let's suppose we have got the C2H6. The structure of C2H6 is actually this one. Okay. So guys, we have to count every single bond. See, 1, 2, 3, 4, 5, 6, 7. So in the given molecule, we have got 7 sigma bonds. As we can see, there is a no pi bond, means there is a no double bond. It means that it won't have any pi bond over there. Copy. Clear, everyone? Are you understanding this? Is it clear to everybody? Copy and confirm. Just copy and confirm. Okay, let's check out the new example. We have got C2H4. So C2H4 is actually look like this. Look at this. Sigma bond, sigma bond. In the double bond, we have got 1 sigma and 1 pi. Sigma bond and the sigma bond. Okay. So we can check out, guys. 1, 2, 3 to 5. 5 sigma plus 1 pi. Okay. Let's check out another example. See. This is sigma bond, this is sigma bond. We know that in triple bond there is a 1 sigma and 2 pi. So we can say that there is 3 sigma plus 2 pi. Okay. I'm giving you a question, guys. You have to count the total sigma and the pi bond. See. Guys, count total number of sigma and pi bonds in the given molecule. Count. and tell me your answer. First of all, copy this one. After copying that, you have to count the sigma and pi bonds. Okay, tell me the answer. Okay. Shillong, what's your answer? Okay, we have got different answers. Okay, now it is same. Good. Count sigma, sigma, sigma pi, sigma, pi, sigma, 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 2 pi, sigma. So 3 to 5 or 3, 8 sigma plus 4 pi. Very good. Attempt this one. Count sigma and pi bond. Attempt this one. Okay, let's see. What about you, Shillong? Okay, let's check out. See, sigma, 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 sigma pi, sigma, 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 sigma pi, sigma, 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 sigma pi. So let's check out. 1, 2, 3, 4, 5, 6 and 6, 12 should be sigma plus 3 pi. This is the answer. Copy. So guys, this is how we can count the sigma and the pi bonds. Any confusion, guys? Clear to everyone? Shillong, Kohima, guys, is it clear to everyone? Okay. So, guys, uh, that's all about for today's session. So, I'll see you next time. Revise again the concept that we have discussed today. Okay. So, see you next time, guys. Till then, take care. Bye bye. Stay healthy. See you next time.